Hello all. In the lecture series spectroscopy, in the previous series, we learned what is a light and what are the properties of light and the Beer-Lambert's law, which is the basic principle for ultraviolet spectroscopy. So here we discuss about the principles of ultraviolet light and how it is applied for the spectroscopy to understand the properties of molecules. In UV visible spectroscopy, the transition of electrons at various levels by absorption of radiation from the ultraviolet to visible region is plotted in a graph. So the transition of electron takes place when the ultraviolet radiation is interacting with the molecule. And the outcome is given as a graph. So the graph of various absorptivities, that is absorption, on specific level of radiation. Some compound observes in some wavelength. So the wavelength are very specific for certain compounds. This is because of absorption capacities of the compounds. The compound A can observe at the 230 nanometer wavelength, or compound B can observe at the 440 nanometer wavelength, which means that both are different. If both are same compounds, then the lambda value will be the same. So the absorptivity purely depends upon the absorption capacity of a compound. So how this absorption capacity differs from a compound to compound. So these levels of absorption capacity are the regions of absorption of the compounds are termed as chromophores. A chromophore is an conjugated double bond and single bond, which has delocalized 5 electrons observed due to the formation of the pi bonds. The first compound you see, naphthalene, 1, 2, 3, 4, 5. So the 5 regions, we have a double bond. So the conjugation chromophore is here 5. And the next one, anthracene, 7 is there, and the next one it increases. So when number of conjugation is increasing, then the absorption wavelength region is also increasing. You see, for the first one, the violet color line, it is around 220 nanometer wavelength of maximum absorption. And for the green one, it just increases to around 240 or 250. And for the third one, violet color, it nearly goes to 300. So when the chromophores is increasing, the chromophores is almost present in every compound. This can be deduced by the facts that all compounds, especially the organic compounds, represent this is a major thing to shift the absorption wavelength to the higher region. So the basic working principle in ultraviolet spectroscopy is when a chemical compound absorbs light, you see this can be related with Beer-Lambert's law, which we explained in the previous session. The Beer-Lambert's law is a relation between absorption and the concentration. So here the chemical compound absorb light means it absorbs light, depends upon its concentration. And when it absorbs light, some excitation and de-excitation process of electrons occurs. Excitation means an electron is shifting from a lower orbital to the higher orbital, lower energy to the higher energy level. If we consider like this, two levels, when the electron is in this level, lower level, will observe some light, it gets some energy, so it transfers to the higher level. And if the energy releases, then higher level electron will come towards the lower level. So like this, when a chemical compound observes light, some excitation and de-excitation process of electrons occurs in atoms, which results in the production of distinct spectrum. A spectrum is the outcome of these interactions. So the electromagnetic spectrum here used is the division of electromagnetic radiation based on the energy, frequency, or wavelength of a photon. So we know that already we discussed this in the first session. The electromagnetic radiation is classified from gamma rays to radio waves, either depending on the frequency or depending on the wavelength. See, gamma ray is having very low wave, and radio wave is having very higher wave. And here we are discussing about ultraviolet and visible wavelength radiation. So the ultraviolet is from 200 to 400 and visible region increases up to 800. So nearly from 200 to 800, this region is considered to be an ultraviolet visible region. So when the light behaves in this region is considered as UV and visible light. So our principle in the ultraviolet spectrum is that the light of these wavelengths, when they interact with the chemical compound, what happens? The absorption takes place. How the absorption takes place? The electrons in the orbits get excited by observing these energy levels and it's to excited state. So the amount of absorption is represented by a wavelength region. So in this spectroscopic analysis, when radiation interacts with the chemical species, they can cause transition at different energy levels. The type of transition depends upon the energy of radiation and the detection method. So like this, depending upon different compounds and their chromophore characters, the wavelength varies. So based on this, we can identify the type of a compound. Thank you.